All right, so on page 7 of your packets. All right. So we're dealing with exponents that are anything raised to the 0 power, anything raised to a negative exponent, and anything raised to a rational exponent, which rational is just another name for fraction. All right. So first off, let's just go through and do some of these examples. All right. So just evaluating exponents. So 3 to the 4th. You can put this in your calculator if you don't know, but what is 3 to the 4th? 81. What's 3 cubed? 27. We did that in the warm-up. 3 squared? 3 to the 1st. 3. So all these you should know, at the very least. All right. Now, if you put 3 to the 0 power in your calculator, what does it give you? It gives you 1. Now, these next ones, all right, in your calculator, put in 3 to the negative 1. What does it tell you? So it should be 0.3, and it's repeating. Now, as a fraction, what is that? So, if you don't know what that is as a fraction, here's how you figure it out. If it will load up. All right. So, in your calculator, I just put in 3 raised to the negative 1 power. I hit enter. I got 0.333 repeating. Now, does anyone remember, because I know I've shown y'all before, how to convert that to a fraction in your calculator? What key do I hit first? If you had me for Math 1, I definitely showed you this. Not quite. All right, so know how to do this because this is really easy. You just hit the math key, which is that key below the green alpha key. Do you see how it says frac right here? All right, hit enter. And then hit enter again. Now that decimal's a fraction. And it's in its simplified form. All right, so not only is it 0.333 repeating, it's also 1/3. So put 3 to the negative 2 power into your calculator, and I want it as both a decimal and a fraction. All right, so what'd you get for 3 to the negative 2 as a decimal? 0.1 repeating. What is it as a fraction? Someone else. 1/9. Now, this one's a typo. It just repeated itself twice. All right, put 3 to the negative 3 in the calculator. Tell me what you get as a decimal and as a fraction. So 0.037 repeating. What is that as a fraction? 1/27th. Good. And then finally, 3 to the negative fourth. I want a decimal and a fraction. So what is it as a decimal? 0.12. 1, 2, 3, and it repeats. What is that as a fraction?
1/81.
1/81. Is there an extra 0 in front of it? I think there is. So that. All right, now, before we do 3 to the negative 77, because that's going to be a really big number, or actually it's a really small number, what do you kind of notice with the negative exponents? What's kind of going on? Specifically the fractions. So look specifically at the fractions. What's going on? What do you notice? Well, they're being multiplied by 3, which makes sense because we're talking about powers of 3. Look at the denominator specifically and look at the exponents that we raised to. What's consistent? I'll give you a hint. Look at the ones up top. So the non-fractional ones. What do you notice? What's the same?
Like the denominators of the fractions and the results of the exponents.
Right. So if you look right here, I have 3 to the first and 3 to the negative 1. The only thing that changed is that if we write this as 3/1, what's the only thing that changed? They flip-flop, right? Right. They switched places. So the 1's now on top and the 3's on the bottom. Same thing for 3 to the second and 3 to the negative second. If we rewrite this as 9/1, they flip-flopped. All right? And so on and so forth. So what do you think negative exponents do? So we had 4 different examples, and it happened to all 4. So for the 27th, we wrote this as 27/1. We got 1/27. They flip-flopped. Same thing with 81. 3 to the fourth, 3 to the negative fourth. We got some version of 81. First one has the 81 in the numerator because it's a positive exponent. Other one has 81 in the denominator. So what do you think happens with negative exponents? They're the reverse. There's another word for that. It also starts with R. They're the reciprocals. Good. So they are reciprocals of each other. Meaning they flip. So the main rule for positive and negative exponents is that if you have a negative exponent, that is the same thing as 1/3 to the first. In other words, you can just move that negative exponent to the bottom or around the fraction bar and make it positive. So, without putting it in your calculator, and we don't need to worry about what 3 to the 77th power is, but what do you think as a fraction that would look like? So, if it follows the same rules that we've been doing, what do you think 3 to the negative 77th will look like if we want positive exponents only? What were we doing up here? We moved it to the denominator, so this will be 1/3 squared. This will be 1/3 cubed, 1/3 to the fourth. So what's this one? 1 over 3 to the 77th. Now, we're not going to evaluate that because 3 to the 77th, that's going to be like a really, really big number, and your calculator will probably give you scientific notation for that. That means it's too big for the calculator to put it all on the screen. All right? But that is essentially the negative rule. So, the negative property of exponents is if you have x raised to a negative power, that is the same thing as, let's say we put this over 1. We would move the base with its power to the denominator and make it positive. So this would be x to the positive m. Now, on the flip side, if the negative exponent is in the denominator first, we move it to the numerator. All right, so in other words, it can flip-flop around the fraction bar depending on where it is originally. So this would be x to the m over 1, which is just x to the m. So biggest thing with with the negative exponent rule, move the base with the negative exponent to the other side of the fraction bar and make exponent positive. So that's kind of words what you would do with the exponent rules. Regardless of whether it's in the numerator or the denominator, you're going to take that entire base with the exponent included and move it to the other side of the fraction bar. So if it's originally in the numerator, you move it to the denominator. If it's originally in the denominator, you move it to the numerator. And then and once you move it, you can make the exponent positive. That's the big thing. You make the exponent positive by doing that. All right. Any questions on that rule? Now, the 0 rule. So what did I tell you? If you raise 0 to anything, so anything raised to the 0 power is always what? 1. So x to the 0 is 1. 3 to the 0, that's 1. All right. 3x to the 0, that's 1. Now, let me ask you guys this. 3x raised to the 0 power. Actually, no. What's this? Is that 1?
3.
It's 3. Why is it 3 and not 1?
Because you just don't have an x. Use your x's.
But are these the same? Because we said that this is 1. What's the difference?
You're factoring.
Right, the zeros only multiply to the x in this case, but here, what's going on? Multiplies to both of them because of what rule? Starts with a P. Nope. What rule did we just talk about in the warm-up? Starts with a P. Not product. The other P one. Power. There you go. Now, in this case, since the 0 is only connected to the x and there's no parentheses, it's only being applied to the x. So this is technically 3 times 1, which is just 3. So you be careful about that. That also gives us this conundrum. So I have nailed this into you guys with your calculators all the time, especially when you're raising a negative number to a power. So think about this carefully. Which one of these two will give me 1? Only one of these will give me 1. Which one? Top or the bottom? The bottom. Why? Why does the bottom give me 1 and not the top? It's in the parentheses, meaning the negative is applied with the 3. So if we raise negative 3 to the 0 power, all right, that will still give us 1. So what's the answer to the top one? Negative 1. Because remember, if you don't have parentheses, your calculator reads this as negative 1 times 3 to the 0 power. That's how it reads it. That's true for any power raise. So remember how I've drilled that into you guys? Always put a negative number in parentheses in your calculator when you're raising it to a power. Same thing applies here. So be careful about that. Now, let's actually try some stuff with these rules. All right, so let's look at number 1 on the next page. So, what I always tell my students is if there's no denominator, always just put it over 1, especially if it's a negative exponent. Because what's going to happen? So what do you think I'm going to do with that x to the negative 14th? So think about it this way. Whenever we simplify, this is how I know that simplified. So here's how I know that I have simplified so this is how I know if I simplified fully. I have no power rules left. I have no negative exponents, so they're all positive. I have no 0 exponents. I only have 1 of every base. And any number fractions are simplified. So I would write this down. This is how you know if an expression is fully simplified. There's no more power rules. There's no negative exponents, so all the exponents are positive. There's no 0 exponents. We have 1 of every base, meaning if you have multiple a's in the problem originally, you should only have 1 a at the end. And if you have any numerical fractions, so like in the warm-up, we had 27 over 6, we simplify that down to 9 over 2. You got to make sure those are simplified as well. All right. So my question still remains. X to the negative 14th power, what do I do with it so it has a positive exponent? What does the negative exponent rule state? We just talked about this on the previous page. What does it do? We do what? Not necessarily parentheses. We literally just talked about this on the previous page. We change its position. Where's it going to go? Right, to the bottom or the denominator. So we're going to take this entire base and move it to the denominator. So the numerator becomes 1 and the denominator becomes x to the, and what happens when I move it? It becomes positive. So this is x to the 14th power. All right. Look at number 2. So we got negative exponents again. So what do I need to do with the y to the negative 8? I switch it where? It goes to the top. So this becomes y to the positive 8 over 1, or just y to the 8th. What about 3? What do I do here? I move it where? Move it to the top again. This becomes 3 cubed over 1, or just 3 cubed. And what's 3 cubed? 27. So guys, if you have numerical bases and the exponents are small enough, just stick them in your calculator and get the number for them. So like if you have a squared or a cubed, I expect you to give me those numbers. All right. All right, 4. That's an easy one. What is it? 1. All right, now let's look at one where there's a little bit more to it. So here's kind of my thing. It does not matter which rule you do first. You can either move the negative first, or what other rule can we do first? So we can either move the negative exponent first, or what's the other rule I could possibly do? Not the power. Not necessarily like terms, but you're on the right track. They are like bases. It's one of the other rules that we just discussed this morning. Starts with P and it's not power. What operation am I technically doing here? Am I doing multiplication, division, addition, subtraction? What am I doing? Come on, guys. I know it's Monday, but come on. Product rule. Good. We're multiplying them. So in other words, I could do what with the exponents first? Not multiply. We're multiplying the bases, but with the exponents, we have to combine how? Addition. All right. So you can either do the product rule first, or you can move the exponent first. All right. So I'm going to show you both ways. So let's say I do the product rule first. If I did the product rule first, all right, that means I'd have 6 to the x to the 4 plus negative 10. All right. Now, what's 4 plus negative 10? Negative 6. This would be 6x to the negative 6. Now, is that fully simplified? No, because what do we not like in our final answer? Negative exponents. So what do I need to move to the bottom? So what do I need to move? Not the whole thing. Because what's the negative only applying to? The x. It's only applying to the x. So be careful about that. The 6 stays in the numerator because it's not being raised to a negative power. The x is the only one. Remember, 2 different bases. So only the x to the negative 6 is getting moved. So this would be 6 over x to the 6. Now, that's if we did the product rule first. But let's say we did the negative rule first. So I started with this. I'm going to put that over 1. What's the only thing I'm going to move? The x to the negative 10 is the only thing I'm moving. So this would be 6x to the 4th over x to the 10th. Now, is that fully simplified? No, because what I say you always have to have one of. We can only have one x written. All right, we have 2, x to the 4th and x to the 10th. So what rule can I do now? Not product. What operation is this? A fraction bar is usually another way you can write what operation? Division. So it's the quotient rule. All right, so how do I do the quotient rule? We subtract. And I always do what? Big minus small. So I do x to the 10 minus 4, which is x to the 6. And where do I put that x to the 6 back at? In the denominator. And remember, whatever was in the smaller one will cancel out, so you can cross it out. So this would be 6 over x to the 6. So regardless of which rule you do first, you get the same thing. So this is one of those where you can skin a duck multiple ways, okay? So, in other words, there's really no correct order for how you do the rules, as long as you recognize that there's more than one rule that needs to be done. So it's whichever feels easiest to you. If you want to do the product rule first, go for it. If you want to do the negative rule first, go for it. Yeah. Now, let's look at this. So, if we look at number 6, what's something that's very easy to take care of right off the bat? The 0 power. What is it? 1. So we can just cross that out. Because it's all being multiplied together. Anything times 1 is itself. Now, we do have a negative exponent, so I want to make sure this is over 1. What's the next thing I need to do, guys? So, am I fully simplified yet? No. What's the problem? The negative exponent's right here. So what do I need to do with it? Nope. Because it's not like bases. X and Y are not like bases. So all I can do is do what to it? What have we been doing with negative exponents? Moving it. So the y to the 5th still stays up top. And then we put x squared on the bottom. And that's your final answer. Since they're not like bases, we can't do anything else. Is everyone understanding what's going on so far? All right. Now, this one. A couple of different ways we can do it. So we can either do a quotient rule first or the negative rule first. Which one do you want me to do first? So you want me to move the negative first, or do you want me to do the quotient rule first? All right, let's move the negative first. What's the only thing I'm moving? Be the negative 3, and that's going to the denominator. So this would be a to the 12th over a to the 5th, b to the 5th, times b cubed. So what rules do you see that I can do? What's one rule that I can do next? There's 2 rules that I can do here. Come on, guys. It's the same people answering. Get with it. What's the next rule I can do here? So guys, of the rules that we've learned so far, not just today, but over the course of this unit so far, what can I do next? And there's no correct answer. Well, there are 2 correct answers here, but the order doesn't matter. What do you want me to do first? Which rule? Combine the what? The b's. So in other words, that's the what rule? Not power, product. All right. So I'm going to combine the b's. How? Add them. So this would be a to the 12th over a to the 5th, b to the what? What's 5 plus 3? 8. All right, so the b's are done. But I still have 2 a's. How can I get the 2 a's down to 1 a? What rule is going on right here? Quotient rule. So I need to do what to the exponents? Subtract them. So if I do big minus small, so that's 12 minus 5, so that's a to the 7th. And where's that a to the 7th going to go? On the top. So you can cross out the a to the 5th. It's gone. A to the 7th is going to go on the top. So my final answer is a to the 7th over b cubed. Not b cubed, b to the 8th, my bad. Any questions? All right. Let's do let's do number 13. Now, 13 looks just terrible, except what's going to happen? This is actually one of the easiest problems ever. Why? The answer is just 1. Why? It's all raised to the 0 power. So what's going to happen is that every base in here is going to get multiplied by 0. And we know that anything multiplied to 0 is always what? Multiplied by 0. What's 0 times 1? 0. What's 2 times 0? 0. What's negative 3 times 0? What's x times 0? What's x times 0? 0. Anything times 0 is 0. So if you have a power rule and it's all raised to the 0 power, everything in there is automatically 1. So you could have, spent time simplifying the inside, but you would have been wasting your time because since it was raised to the 0 power, it would just all become 1 anyway. All right, let's look at 17. Now, this is kind of up to you. You can either simplify what's in the parentheses first, or you can do the power rule first. It really doesn't matter. What do you want to do first? Let's do what's inside the parentheses first. Like, just simplify everything in there, so all we have to worry about is the power rule at the end. So what's one thing I can simplify inside the parentheses? The 0 power. So d to the 0 power. So what happens? Come on, heads up, guys. It's 1. So it's just the d that goes away, not the 8. Why not the 8? Right, the 0 is not connected to the 8. There's no parentheses there. What else can I simplify? The c to the 5th or negative 5th, and where can it go? The bottom. So this is 4 over 8c to the 5th, and it's all raised to the 3rd power. There's one more thing I can simplify before I do the product rule. Not product rule, power rule. What's the last thing I can simplify in those parentheses? The numbers. 4 over 8 simplifies down to what? 2 over 4 or 1 over 2. This would be 1 over 2 c cubed. Now it's still all raised to the 3rd power. So now I can do the power rule. So I'm going to put my 1s next to all my bases so I don't forget about them. I'm going to multiply the 3 to all 3 of these. So this would be 1 cubed over 2 cubed. C to the what? What's 3 times 3? 9. And then I simplify where I can. What's 1 cubed? 1. 1 raised to any power is always 1. What's 2 cubed?
8.
8. And then c to the 9th remains. We could have done the power rule first and gotten the exact same thing. It really doesn't matter. All right, let's see how adept you're at this. Try 19 on your own. So try 19 on your own.
get you the new packet for mathematically getting the
All right, guys, make sure all of you are trying this problem. My little sleep babies, I know you just came back from break. Wake up. I gotta be awake, you gotta be awake. Well, just pick some more time. So, what would you recommend? Or technically negative.
What?
if you're tracking them way to minus 85.
So guys, it doesn't really matter what rule you pick to start with, just pick something and roll with it. If you're stuck, talk with your group mates.
Okay.
Annie, North Carolina.
All right, guys, I'm gonna give about 1 more minute. We'll talk about it. Well, we're gonna talk about it. Don't pull my No promises. It's luck of the draw. All right, so let's start with Luke. What is one rule that I could do first? So there's not really any product rules in here. So it's really only quotient rule and negative rule. But it doesn't really matter which one I want to do first. Which one do you want to do first?
Oh, we can do the negative 2W and the negative 5W.
Okay, we can do the quotient rule. So if we do the quotient rule, we'll start with the W's. Technically, which one's bigger? The negative 2 is bigger. So I'm going to do W raised to the negative 2 minus negative 5, which is what? What happens to these two negatives right here? They become positive. So this would be W raised to the what? Negative 2 plus 5 is? Same thing as 5 minus 2? 3. And where's that W cube going to go? To the top, because that's where our biggest one was. So I'm going to X out the negative 5. This is going to go to the top. So I have negative 2 W cubed over 6. I still got the Y's. All right. Now let's go Caden with a C. What's another rule I could do? I can do what? We can do the Y's. So we can do another quotient rule with the Y's. So if I do big minus small, which one's my big? The 3 is my big. So I'm doing 3 minus negative 2. All right. So that's a plus. So what's 3 plus 2? 5. Now where's it going to go, top or bottom? It's going to go in the bottom because that's where my big was. So we can cross that one out. So I have negative 2 W cubed over 6Y to the 5th. Now, we've exhausted all of our exponent rules because we have one of every base. And if you look, all the exponents are positive. Remember, this negative is on the outside. It's not in the exponent. It's just saying we have a negative 2. All right. So what's the final thing I need to do to simplify F from?
Make sure about these.
The numbers?
Yeah.
Right. So in other words, we need to simplify that fraction. What's negative 2 over 6 simplified down to? Negative 1/3. So this is negative 1 W cubed over 3Y to the 5th, which we can rewrite as W cubed negative over 3Y to the 5th. So guys, it doesn't really matter where you start. You could have done the negative rule first and moved all the negatives around. It doesn't matter. You just need to pick something and roll with it. All right. If you recognize that you had a quotient rule because you had one base in the top, one base in the bottom, do the quotient rule first. As long as you recognize which one's the bigger one. So when you deal with negative numbers, that's when it can get a little dicey with the quotient rules. All right. If this was me, I probably would have done the negative rule first. All right. So I had everything positive to play with. All right. But again, it's up to you. You got to get okay with these. Okay, moving away from negative exponents. The last thing we got to talk about today is fractional exponents, also known as rational exponents. Now, so this is review from the last unit, but if we multiply two of the radicals with the same radicand underneath, the same number underneath, we just get positive 3. Because remember, I can rewrite square root of 3 times the square root of 3 as what? What's that the same as? The square root of 3 what? Squared. And what happens when you square a square root? They cancel out. So that's how we get 3. All right. Now, if we're talking product rule, that means we get 3 of the first. What number, and this number is going to be a fraction, what number, if I add it to itself, gives me 1? So what fraction, if I add it to itself, it gives me 1? 0.5, right. So 0.5, which what is that as a fraction? What's 0.5 as a fraction, guys? Come on. It's what? If you guys don't know what 0.5 is as a fraction, I'm concerned. 0.5 plus 0.5 is equal to 1. So 1/2 plus 1/2 is equal to 1. So that means that 3 to the 1/2 times 3 to the 1/2 is 1 by product rule. So can we not say that these two are the same? Did we not get the same thing? All right, let's try another example. So we know that square root of x times the square root of x is going to be x, because again, same thing as square root of x all squared. Those cancel out. That's what gives us the x. So what fraction add together to itself gives you 1? Did we just say? 1/2. So x to the 1/2, x to the 1/2 is equal to 1. So, thank you. So square roots can be written as an exponent of 0.5, which that is 1/2. Not x, sorry. This should be written as an exponent of 1/2. So that is, if you have the square root of x, it's the same thing as x to the 1/2. So if you ever see x to the 1/2 or 3 to the 1/2 or 9 to the 1/2, it's the same thing as the square root of that value. All right. Now, what are these roots called if they have little 3's in the corner? So this isn't a square root, it's a what? It's a cube root. All right. So that means this is cube root of 5. Now, we're multiplying it to itself 3 times. So that means we're doing what to that cube root of 5? If we multiply it to itself 3 times, the same thing as doing what to it? Cubing it. So just like how a square root and a square undo each other, what do you think a cube root and a cube do to each other? They undo it. So they cancel each other out. And that's how we get 5. Now, think way back to kindergarten. We want a whole, but we want to break it up into 3 pieces. All right? We want a whole, but we want to break it up into 3 pieces. So what should each of these fractions be? 1/3. So, same thing here. Just as the cube root of x, or x, the cube root of x cubed is equal to x because they cancel each other out. X times itself, x raised to the 1/3 power times itself 3 times is x to the first. So that means a cube root can be written as an exponent of 1/3. Meaning, if you have the cube root of x, that is the same thing as x raised to the 1/3. Now, why is this important? A lot of times in math, when you start throwing in like square root symbols and cube root symbols and you're simplifying, a lot of times it's easier to convert it to an exponent because then it makes the simplifying easier. All right. So the fractional exponent rule for is if you have an nth root of x to the a, all right, or another way you may see this expression is the nth root of x raised to the a power. It doesn't matter. That's the same thing as x raised to the a over n. So whatever type of root it is, that's always your denominator. And then whatever power you're raising that value to, whether it's under the denominator, under the radical, or it's doing a power rule to it, you put that in the numerator. All right. So just some examples here. That's why 16 to the 1/2. Remember, square roots, there's always an unspoken 2 there. Yes, sir. Yes. All right. And this is technically the 16 being raised to the first power. So that's where you get 16 to the 1/2. All right. So let's try this. So how do I rewrite the square root of 6 using fractional exponents? So first off, what's the unspoken number here? What type of radical is this? Is it a cube root, square root, fourth root? What type of root is it? Come on, guys. This is easy. What type of root is this? It's a square root, which means the number here is technically a what? 2. Now, this 6 isn't raised to anything, so we're going to put a 1 there. So based off of that rule that I just gave you, so n root of xa is equal to xa over n. What is this? 6 raised to the 1/2. That's all you got to do. If I ask you to switch to exponential form, you just got to give it to me as an exponent. What about this one? So what type of root is it first off? It's a square root, so we put a little 2 there. Now, 11x, we have 2 bases, but technically they're both raised to what power? 1. So I could put those in parentheses as a 1. So be careful. How would I write this? If it's all under the square roots. Now, there's something wrong with this picture. What am I missing? I need to put parentheses around the 11x. Why? Why do I need to do that? Right. So, in other words, I need to make sure this 1/2 isn't just connected to the x. If you don't put parentheses around the 11x, you're saying the 1/2 is exclusively connected to the x. So, again, if you did 11x to the 1/2, that is the same thing as 11 times the square root of x. Not the same thing. So, parentheses matter in this case. All right, so what about this one? So the 2 just kind of stays where it is. It's being multiplied. But we have a cube root, and this is a 1. So this would be 2y raised to the what power? 1/3. Now, do I need to put the 2y in parentheses? Yes or no? No, because only the y is under the radical. All right. If it helps, guys, I don't mind if you write it like this. If that helps you recognize where the exponent is connected to, that's fine. I don't care. All right. If you want to put parentheses around just so you know that's where the exponent's connected to, that base is what it's connected to, that's fine by me. I don't care. Now, let's go in the opposite direction. So let's convert to radical notation. So first off, the 1/2 exponent is only connected to which base? The x. So if it helps, stick that x in parentheses. So the 3 is going to be on the outside. We're going to have some radical. What type of radical is this going to be? Is it going to be a square root, cube root, fourth root, fifth root? What? It's going to be a square root, so there'll be a little 2 here. What's going to go underneath? X or x to the first, just to keep things consistent. If I do a little cleaning up, this will be 3 square root x. What about this one? Someone besides Bella. So is that 1/3? Is it connected to both or just one? Both. So that means they're both going to be under the radical. What type of radical will this be? Is it a square root? It's a cube root. So you need to put a little 3 on the outside. If it helps, you can raise this all to the first power. So I can rewrite this as the cube root of 4y. Last one. That 1/2, is it connected to all or just some of it? All. So that means it's all going to be under a radical. What type of radical is it? It's a square root. So I can put a 2, raise all this to the 1, clean it up. It's just the square root of 5mn. Does everyone understand how fractional exponents work? How you can switch in between the two? All right. Now, that's when the numerator is always 1. But that's not always the case. All right. Sometimes it's not. Okay, so we're going to still use this same rule. All right. So, x to the 1/2, we already know is going to be what? How do I change x to the 1/2 to be a radical? So we know we're going to have a radical with an x underneath it. What's going to go here? 2. What's going to go here? 1. All right. So we call this number the index. So this number right here is called the index. The x is called your radicand. And then whatever it's raised to is still just the exponent. All right. So same thing over here. Exponent is the 1. The root is the 2. That's also your index. The base is the x. So x to the 3/4 in radical form. So we know we're going to have some radical with an x underneath it. What type of radical is it? So what's the index of the radical? What number is going to go outside of the radical? Nope. 4. It's always the denominator. So whatever your denominator is, that's your index. So your denominator is always the type of root it is. Now what's that x going to be raised to? The 3rd power. Now, you may also see it, just so you know, you may also see it as the 4th root of x all cubed. It's the exact same thing. So the 4th root of x cubed and the 4th root of x all cubed, that's the exact same thing. Doesn't really matter how you write it. Just know that you may see it both ways. What about this one? Without me even walking you through it, what's it going to look like? What type of root am I going to have? I'm going to have a cube root. What's going to go underneath? X squared. Good. So again, the other way you could write it is the cube root of x all squared. Again, don't care whichever way is most comfortable to you. It is what it is. They're both the exact same thing. So again, if you are given x to the a over n, That is the same thing as the nth root of x to the a, or the nth root of x all to the a power. So the denominator of the exponent means root. That's the type of root it is. So n is considered your root. Your numerator means that's the power. So a is the power you're raising your value to. All right, so let's do some rewriting. So x to the 3 halves. First off, what type of root am I going to have? Square roots. What's going to go underneath? X cubed. Good. Now, be careful with b. So it's hard to see, but there is a negative here. So before I can even do anything, what do I need to do first? So before I can change it to a radical, what should I probably do first so I don't have a negative exponent? What do we do with negative exponents? We move them. So this would be 1 over y to the 9/8. So that means that whatever radical we write, we're going to put it over 1. So first off, what type of radical do I have? What type of root is it? It's an 8th root. And the y is going to be raised to what power? The 9th. Good. All right, now let's do some evaluating. So let's first convert this to a radical because that'll make our lives easier. All right. Now, this is one we're using. This version is going to be easier. So when you evaluate, I highly recommend using that version. So first off, the negative 27 is not a negative exponent, it's just a negative number. So what type of radical am I going to have? Negative 27 is going to go underneath. What type of radical is it? It's a cube root. And then we're going to square it. Now, here's my question. What's the cube root of negative 27? Not just 3. Negative 3. So this would be negative 3 cubed, which we know to be, not negative 3 cubed, negative 3 squared, which we know to be what? What is negative 3 squared? 9. So that's simplified. All right, does everyone follow how that works? Yes, no, maybe? All right. Now, I'm really only going to do the hard ones for this one. So specifically, let's look at E. Now, we know our answer is going to be over 1. So how do I change the 5th root of x cubed to a fractional exponent? So we know we're going to have x. What's my numerator? So what's the numerator? What's the power? 3. What's the root? 5. What's another way I could write this? So I don't have a fraction? Not a fractional exponent, but so I don't have a fraction. So x to the 3/5, but what has to happen to that 3/5?
It has to become negative.
There you go. That's another way you could write it. All right. Do I need to do any more conversions? Or are you guys okay? Yes, no, maybe. You guys are good? Okay. All right. Last thing we're going to do very quickly. Evaluating, I already taught you how to do that. Honestly, guys, when in doubt, just put it in your calculator. All right. So we got some fractional exponent rules. Let's do a couple of these. So whenever you're doing fractional exponents and you're simplifying expressions with them, do not convert to radicals. Now, if they're in radical form, you're trying to simplify them, then convert them to fractional exponents. All right. But exponent rules still apply. So technically, for this one, what am I going to be doing with those two exponents? You add them. So if I have 2 over 1 plus 1/2. Remember, whenever we add exponents, we always got to have a what? Common denominator. So how can I change this 1 to be a 2? I multiply the top and the bottom by what? 2. This would be 4 over 2 plus 1 over 2, which is what? So remember, once we have common denominators, we can just add the numerators.
5 over 2.
5 over 2. This would be x raised to the 5/2. You can leave it like that, unless it asks for it in radical form. All right. So let's do one like this. Now, quotient rule now. So if I want big minus small, which fraction is technically bigger? 1/2 is technically bigger. So if I do 1/2 minus 1/3, again, gotta have common denominator. What's the common denominator of 2 and 3? What number can be divided by both 2 and 3? 6. So I gotta multiply this one by 3, this one by 2. So this would be 3 over 6 minus 2 over 6, which is what? So you just subtract the numerators. 1/6. Now, that means it'll be x raised to the 1/6. Where's it going to go? Top or bottom? Nope. Where's the bigger one originally? The bottom. Now, guys, you can also do this in your calculator. Just subtract the exponents in your calculator. Just make sure you convert it back to a fraction the way that I taught you to. All right. So this will be 24 over 6 raised to the 1 x to the 1/6. One last thing I got to simplify. The numbers. 24 divided by 6 is just 4. So this will be 4 over x to the 1/6. All right. Last one I want to do is a power rule. Let's look at H. So remember, you multiply it to each fraction. Now, multiplying fractions is easy. So I have 3/2 times 2/3, and I have 3/8 times 2/3. How do I multiply fractions? And do not say cross multiply, because that's not the answer. Straight across. So this would be 6 over 6, which is just what? 6. 1. This would be 6 over 24, which is what? What can be divided into 6 and 24? 3 or 6. So 1 over 4. I'm just going to put them back with their respective values. So this one was an m. This one was an n. So my answer is m to the first, n to the 1/4. I'll also just write as m, n to the 1/4. So make sure you know your fraction operations. But again, calculators are your friend. Just make sure you convert them to fractions. I do not want decimals. All right, no decimals in the exponents. I want fractions only. So if you do in your calculator, just make sure you convert. All right. Okay, any questions on this? All All right, so just so you're aware, you do have a new Delta math that's on all this stuff. All right. You guys should have more work time tomorrow. I know this was kind of a long lesson. All right. So, what I need you guys to do is erase your whiteboards before you leave, put your calculators up, and clean up around your desk.